Right now, there's a piece of software that has literally never spent a single day in medical school.
Right.
Yet it is spotting these microscopic anomalies in medical scans with, higher accuracy than a room full of veteran doctors.
It's honestly incredible.
It is. And then tomorrow, that exact same underlying technology might be quietly generating like your boss's passive-aggressive emails.
Yeah, and probably doing a scary good job at it, too.
Exactly. I mean, we have completely crossed the line from a machine that just does fast math to, well, an invisible intelligence weaving itself into the fabric of everyday life.
We really have is a profound structural shift. We are moving away from software as a passive tool, something you just command to execute a rigid task, towards software as an active interpreting entity. The intelligence is no longer just sitting behind the keyboard.
Right, and that is exactly the mission for you on this deep dive. We are tearing into this massive, comprehensive dossier, tracking the past, the present, and the bleeding-edge future of artificial intelligence.
Yeah, there is a lot to unpack.
So much to unpack. But we are stripping out all the dense academic jargon to answer the only question that actually matters to you. How is the underlying architecture of this technology going to fundamentally rewire your career, your media, and your daily routines?
Yeah, and to really understand the trajectory we are on right now, we have to look at the mechanics of how we even arrived here.
Right.
I mean, the concept of creating a synthetic mind, it's been a philosophical obsession for centuries. But the structural foundation for the current moment, that was poured in the mid-20th century.
Yeah, the dossier kicks off this timeline with Alan Turing in 1950.
Oh, the Turing test.
Exactly. He proposed the imitation game. Basically, if a machine can fool you into thinking it's human through a text conversation, it is, for all practical purposes, intelligent.
Right.
But I want to fast forward just a bit to 1956, to the Dartmouth College Summer Research Project, because this is where the sheer hubris of early computer science really fascinates me.
Hubris is definitely the right word for it.
Right. They gathered the brightest minds and legitimately believed they could map and replicate human intelligence over a single summer vacation.
Yeah, they really did. And, well, they believed that because their entire paradigm was built on symbolic AI.
Okay, break that down for us.
So they viewed human intelligence as just a series of logical deductions. Their hypothesis was that if they could just write a massive, exhaustive set of rules, like if A, then B.
Just hard code everything.
Exactly. They thought they could codify the entire human experience into an instruction manual.
Which is, that's like trying to build a train to navigate a dense jungle.
Oh, that's a good way to put it.
Because a train on a track is incredibly fast and efficient, but it requires a perfectly engineered environment, right?
Yeah.
If a tree falls on the tracks or, if the computer encounters a messy real-world scenario that isn't perfectly outlined in its little rule book,
Right.
the entire system just derails.
That is the perfect way to visualize the expert systems they built in the 1980s.
Right.
These were highly specialized programs used in finance and medicine. And they were brilliant at closed-loop logic, but they lacked any off-road capability whatsoever. The researchers basically ran face first into Moravec's paradox.
Moravec's paradox. I saw that in the sources. Walk us through the mechanics of that.
So it's the observation that high-level reasoning requires very little computation, but low-level unconscious sensory perception, like just seeing or walking, requires enormous computational power.
Interesting.
Yeah. So teaching a 1980s computer to calculate millions of potential chess moves, that was relatively easy.
Because chess is just math.
Exactly.
Yeah.
Chess is a closed system with perfect information. But teaching that exact same computer to look at a photograph and distinguish a cat from a crumpled up sweater?
Impossible.
It was mathematically impossible at the time. You just cannot write a logical rulebook for the shape of a cat.
Because the real world is infinitely variable. Like the lighting changes, the angles change.
Exactly.
So all that initial hype just hits a brick wall. And the funding completely evaporates, which pushes the industry into what the researchers call the AI winters of the 80s and 90s.
Yeah, deep freeze.
The entire field basically went on ice because the whole train-on-tracks approach fundamentally failed at mimicking biology.
Right. And to break out of that winter, the industry had to abandon the rulebook entirely.
They had to build off-road vehicles.
Basically, yeah. We had to move from symbolic AI to artificial neural networks. Instead of telling the computer exactly how to solve a problem, you build a massive web of artificial neurons.
Okay.
You feed it a staggering amount of data, and you just let it adjust the mathematical weights of its own connections until it recognizes the pattern itself.
But the dossier points out that neural networks aren't actually a new concept. Like, the theory existed for decades.
Oh, absolutely.
It just didn't work until a very specific technological trifecta aligned.
Yeah, it required 3 simultaneous explosions in capacity to really work. First, we needed massive data sets to expose the networks to enough examples, which, the birth of the internet
Well,
provided.
suddenly we have all this digitized data.
Exactly. Second, we needed advanced deep learning algorithms to structure all that learning. And fundamentally, we needed the hardware to actually process it all at once.
The GPUs, graphics processing units.
Right, GPUs. So traditional computer processors, CPUs, they are like a single brilliant processor. They execute one complex task at a time very, very quickly. But GPUs were originally designed for video games to render millions of individual pixels on a screen simultaneously.
Wow, okay.
Yeah, and it turns out that parallel processing, basically thousands of slightly less brilliant workers doing simple math all at the exact same time, that is the exact hardware architecture required to train a neural network.
So the hardware catches up to the theory, the internet provides the training data, and suddenly the machine isn't just playing chess anymore, it's defeating the world champion at Go.
Which is wild.
A game with more potential board configurations than there are atoms in the observable universe.
Yeah.
But, the inflection point for the broader culture wasn't a board game. It was this shift into the generative era.
Oh, definitely.
It was this sudden realization that these networks could not just recognize a pattern, but actually predict and generate the next piece of a pattern.
And that brings us to the current paradigm, which is defined by the leap into multimodal systems. This is a crucial mechanism to understand.
Yes. Break that down.
We aren't just talking about a large language model predicting the next word in a text document anymore. A multimodal AI processes text, audio, images, and video inside the exact same mathematical structure.
And this concept of the latent space from the dossier, this is where the technology stops feeling like software and honestly starts feeling like magic to me.
Yeah, it's mind-bending.
Because it isn't taking an image, translating it to text, and then reading the text. It maps everything into this massive, multi-dimensional coordinate system.
Right, it creates relationships between vastly different types of data. So in this latent space, the audio file of a dog barking, the word dog, and a video of a golden retriever, they all map to the exact same mathematical neighborhood.
Wow.
Yeah. That is why you can literally point your phone's camera at the inside of your refrigerator, ask the AI out loud what you should make for dinner, and it can generate a recipe based entirely on the visual input of your leftovers.
Which is amazing. But it's also why my image generator used to spit out terrifying pictures of people with 7 fingers, right?
Yeah. The hands.
It didn't actually know what a human hand was structurally. It didn't understand bones or joints at all.
Yeah.
It just mathematically associated a certain cluster of pixels with the word hand.
Exactly. And that is the inherent friction of generative models. They do not possess a world model.
Okay.
They are probability engines. They are astonishingly good at predicting what should come next based on their training data, but they don't actually understand the physics or logic of the things they are generating.
Right. But that same mathematical pattern matching that generates an image is exactly what is driving the algorithms you interact with constantly.
Oh, everywhere.
We talk about AI as this new frontier, but honestly, it has been the invisible assistant running your life for a decade.
Absolutely.
It's the engine analyzing millions of data points to serve you the exact YouTube video that will keep your eyes glued to the screen. It's the fraud detection at your bank, mapping the latent space of your purchasing habits.
To instantly freeze your card if a transaction falls outside your normal cluster of behavior.
Exactly.
And we are seeing that exact same probability mapping revolutionizing healthcare right now. A modern medical AI analyzes an MRI. It breaks the image down into millions of pixels and compares it against a vast database of malignant and benign scans.
Okay.
And it essentially says, hey, there is a 94% probability that this specific cluster of pixels matches the pattern of an early-stage tumor.
Now, our sources are incredibly strict about the boundaries here, though.
Yes, very strict.
In a high-stakes environment like an oncology ward, the AI is not making the diagnosis.
No.
It's a highly sensitive radar system. It flags the anomaly, but the human oncologist, who actually possesses medical context, ethical oversight, and a physical understanding of the patient, they make the final call. The human is the fail-safe.
Right. It's the concept of human in the loop. The AI augments the professional. It doesn't replace them. But as we move into less regulated sectors, like media and content creation, That loop is closing fast.
Oh, the leverage is astronomical.
Mm.
I mean, a solo creator can prompt an AI to outline a marketing strategy, generate the copy, design the graphics, and write the underlying HTML for a landing page in under an hour.
It's crazy.
You essentially have an entire digital agency at your fingertips. But the inevitable result of giving everyone a hyper-efficient printing press is a massive degradation in the signal-to-noise ratio.
Yeah, the clutter.
The internet is just rapidly filling up with synthetic, perfectly average, machine-generated clutter.
Which forces a very uncomfortable conversation about education, actually. This is where the tension between automation and comprehension becomes really critical.
Yeah, let's get into that.
Yeah.
Because if a student uses an AI tutor to break down complex calculus into a personalized analogy that can actually understand well, that is a profound enhancement of learning.
Absolutely.
But if they prompt a multimodal model to instantly generate a 10-page essay on a novel they never even opened, well, the AI is essentially automated away the cognitive struggle.
Right.
The neural pathways in a human brain don't form if the artificial neural network is doing all the heavy lifting.
Exactly. The tool itself is mathematically neutral. The application determines whether it acts as a cognitive scaffold, building the student's mind, or a cognitive crutch, letting it atrophy.
Automating away the thinking brings us directly to the immediate, tangible stakes for you, the listener. Because the double-edged sword of this technology isn't just about lazy students.
No, definitely not.
It's about the rapid erosion of consensus reality.
We are tracking severe vulnerabilities right now. I mean, the architecture that allows an AI to generate a beautiful piece of art is the exact same architecture used to generate a deep-fake video of a politician declaring war.
Right. And let's look at the mechanics of voice cloning. Because this is a massive vector for fraud right now.
It's terrifying.
It doesn't need to splice together old recordings of you speaking anymore. It just takes a 3-second sample of your voice, maps the acoustic, features your pitch, your timbre, your unique breathing patterns into that latent space, and synthesizes entirely new audio. It can call your relatives in the middle of the night using your exact vocal tract, claiming you are in the hospital and need money wired immediately.
And that's the thing. The barrier to executing a highly sophisticated, emotionally manipulative phishing attack has dropped to literally zero.
Wow.
When the cost of generating convincing synthetic media approaches zero, trust becomes the most valuable currency in society.
Trust. Yeah. And if we look at the workforce, I mean, people aren't just worried about deepfakes. They're worried about obsolescence. Are we really looking at a mass deletion of white-collar jobs?
So the data presents a more nuanced reality here. The jobs most vulnerable are those that function essentially as a human API.
A human API, what does that mean?
Well, if your daily work consists of extracting data from an email, summarizing it, and pasting it into a spreadsheet, you are acting as a piece of connective tissue between software programs.
Okay, I see.
That layer of work is being automated incredibly fast.
I look at it this way. The primary survival skill for the next decade has nothing to do with learning Python.
No.
It is domain expertise. It is the ability to interrogate the machine. If the AI is a 1,000-horsepower engine, it will simply drive you into a wall 1,000 times faster if you don't know how to steer.
That is a great analogy.
You have to possess enough fundamental knowledge in your field to look at the output, spot the subtle hallucinations, and know exactly which questions to ask next. Blind trust is just a career-ending liability at this point.
Which is exactly why the roadmap for the next 5 years is so critical. If the current models are fast engines, the next phase of development fundamentally upgrades the navigation system entirely.
Okay, let's talk about the future.
The dossier outlines 4 massive shifts between now and 2030, starting with the transition from assistants to agents.
Right, because up to this point, generative AI has been mostly reactive. I ask it to write a recipe, it writes a recipe,
Yeah.
and then it just stops.
Exactly.
What is the actual mechanism behind an AI agent?
So an agent possesses a degree of autonomy driven by what we call agentic loops, or chain of thought reasoning.
Okay.
Instead of giving it a micro prompt, you give it a macro goal. You don't ask it to write an email to an airline. You tell the agent, book me a flight to London under $800, find a hotel near the conference center, and update my calendar.
And the agent actually breaks that down into subtasks.
Yeah.
It queries the airline website. If it gets a software error, it doesn't just give up and ask me what to do. It writes a quick Python script to scrape the pricing data, evaluates the options against its budget constraint, selects the flight, inputs the payment data, and then just moves on to the hotel.
Exactly.
It is essentially having a constant, iterative conversation with itself until the macro goal is achieved.
And that autonomous reasoning capability is what enables the second major shift. AI stepping out of the latent space and into the physical world.
Okay, robotics.
Yeah. For the last 10 years, artificial intelligence has been trapped behind the glass of our monitors. But by 2030, we will see the widespread deployment of vision language action models, or VLAs, inside physical robotics.
Meaning you don't have to program a robot with the exact spatial coordinates of a coffee cup to get it to clean a table.
Precisely. You integrate a multimodal model into a robotic chassis. The robot uses its cameras to ingest the visual data of the messy table. It uses its language model to understand the verbal command, clean this up. And it uses its action model to deduce the physical steps required to pick up the cup and place it in the dishwasher.
That is wild.
It really is. This unlocks dynamic, autonomous systems in manufacturing, agriculture, and eventually consumer home assistance.
But taking a probability engine and giving it a physical body that can move through a factory floor or your living room, that makes the third shift from our dossier incredibly urgent.
Oh, the regulation.
Yes, the era of move fast and break things is completely colliding with international law.
Yeah, we are looking at the rollout of the European Union's AI Act, which officially entered into force in August 2024 with rolling compliance deadlines through 2028.
Right.
It is a risk-based regulatory framework that completely alters the market. It outright bans certain applications like real-time biometric categorization in public spaces, but its biggest impact is on the foundational models themselves.
It demands transparency. Like, you can't just scrape the entire internet in secret anymore.
No, not at all.
If you want to sell your AI in the European market, you have to prove exactly what data you trained it on, and you have to map out your cybersecurity vulnerabilities.
Yeah.
Enterprises are realizing that a model with maximum computing power is totally useless if it exposes them to massive legal liability.
And that enterprise adoption is the fourth and final pillar in the dossier. The Stanford HAI Index data tracks an unprecedented scaling of financial investment right now.
Big money.
Trillions. Corporations aren't just experimenting with chatbots anymore. Trillions of dollars are being poured into the physical infrastructure, the server farms, the energy grid, the cooling systems required to embed these agentic models into global supply chains, finance, and logistics by 2026.
So, distilling this massive timeline down for you, the defining challenge of the next few years is not about building a bunker and trying to hide from the algorithm.
No, you can't.
The economy is rewiring itself entirely around this architecture. The challenge is conscious adaptation. It is figuring out how to utilize these models to strip away the administrative friction of your work so you can double down on the high-level critical thinking that the machine still fundamentally lacks.
I think that's exactly right. The story of artificial intelligence, from the naive optimism of the Dartmouth Conference in 1956 to the multimodal neural networks navigating our physical world today, is essentially humanity's attempt to map its own cognition. We are basically building a synthetic mirror.
A synthetic mirror. Which brings us right back to the Turing test we started with.
Yeah.
Turing said the goal was to build a machine indistinguishable from a human being. But consider the mechanism of how we are actually building it. These foundational models are trained on the entirety of the internet. They've ingested all of our highest achievements, our art, our medical research, our poetry, but they have also ingested the darkest corners of our data, our deep systemic biases, our anger, our historical flaws, and our infinite contradictions.
That's very true.
If the ultimate goal is a machine that perfectly replicates the human mind, when that AI finally passes the test and acts perfectly, undeniably human, are we actually going to like what we see looking back at us?